Hi students, I am Praveen Sebastian Paul. From this lecture onwards, we are discussing the digital logic gates. The digital logic gate is a basic building block from which all digital electronic circuits and microprocessor based systems are constructed from. Basic digital logic gates perform logical operations like AND, OR, and NOT operation on binary numbers. In digital logic design, only two voltage levels or states are allowed, and these states are generally referred to as logic 1 and logic 0, or high and low volt, or true and false states. These two states are represented in Boolean algebra and standard truth tables by the binary digits 1 and 0 respectively. A good example of digital state is simple light switch, as it is either on or off but not both at the same time. In Boolean algebra, it is represented as logic 1 and logic 0. In Boolean logic, it is represented as true T or false F. And in voltage state, it is represented as high voltage H or low voltage L. Most digital logic gates and digital logic system uses positive logic, in which logic level 0 or low is represented by a 0 volt 0V or ground, and the logic level 1 or high is represented by higher voltage such as plus 5 volt, with the switching from one voltage level to other, from either a logic level 0 to a 1 or 1 to a 0, being made as quickly as possible to prevent any faulty operation of the logic circuit. There also exists a complementary negative logic system in which the values and rules of logic 0 and logic 1 are reversed, but in this tutorials we are discussing the logic gates with the positive logic conventions, as it is most commonly used. In standard TTL, that is transistor logic circuits, there is predefined voltage range for the input and output voltage level, which define exactly what is logic 1 level and what is logic 0 level, and these are discussed as follows. The digital logic gates may have more than one input A, B, C, etc., but generally only have one digital output. The individual logic gate can be connected together to form combinational or sequential circuits or larger logic gate functions. The standard commercially available digital logic gates are available in two basic families or forms, that is TTL, which stands for transistor logic, such as 7400 series, and CMOS, which stands for complementary metal oxide silicon, which is the 4000 series of chips. This notation of TTL or CMOS referred to as logic technology used to manufacture the integrated circuits, or a chip as it is more commonly called. Generally speaking, the TTL logic IC use NPN and PNP type bipolar junction transistors, while CMOS logic IC use complementary MOSFET or JFET type field effect transistor for both their input and output circuitry. As well as the TTL and CMOS technology, simple digital logic gates can also be made by connecting together diodes, transistors, and resistors to produce RTL, resistor transistor logic gates, DTL, diode transistor logic gates, or ECL, emitter coupled logic gates, but these are less common now compared to the popular CMOS family. The integrated circuits, or simply ICs, as they are more commonly called, can be grouped together into families according to the number of transistors or gates that they contain. For example, a simple AND gate may contain only a few individual transistors, whereas more complex microprocessors may contain thousands of individual transistor gates. Integrated circuits are categorized according to the number of logic gates or the complexity of the circuits within a single chip, with the general classification of the number of individual gates given as follows. The different classifications of ICs are: small scale integration, or SSI, contains up to 10 transistors or a few gates within a single package, such as AND, or NOT gate. Second one is a medium scale integration or MSI. It is between 10 and 100 transistors or tens of gates within a single package and perform digital operations such as adders, decoders, counters, flip-flops, and multiplexers. The third one is large scale integration or LSI. It is between 100 and 1000 transistors or hundreds of gates and perform specific digital operations such as input-output chips, memory, arithmetic, and logic units. The fourth one is the Vlsi technology or very large scale integration. It lies between 1000 and 10,000 transistors or thousands of gates and perform computational operations such as processors, large memory arrays, and programmable logic devices. Another one is SLSI, that is super large scale integration, lies between 10,000 to 1 lakh transistors within a single package and perform computational operations such as microprocessor chips, microcontrollers, basic PICs, and calculators. The last one is the ultra large scale integration, that is ULSI. It consists of more than 1 million transistors, the big boys that are used in computer CPUs, GPUs, video processors, microcontrollers, FPGAs, and complex PICs. While the ultra large scale ULSI classification is less well used, another level of integration which represents the complexity of integrated circuit is known as system on chip or SoC for short. Here the individual components such as microprocessor, memory, peripherals, I/O logic, etc. are all produced on a single piece of silicon and which represent a whole electronic system within one single chip, literally putting the word integrated into integrated circuit. These complete integrated chips, which can contain up to 100 million individual silicon CMOS transistor gates within one single package, are generally used in mobile phones, digital cameras, microcontrollers, PICs, and robotic type applications. So my dear students, from the upcoming lecture we are discussing the basics of these transistors, that is basic logic circuits like AND gates, logic OR gates, logic NOT gates, XOR gates, etc. So my dear students, we will discuss in detail about these in the upcoming lectures. So see you soon. Until then, goodbye, thank you, and all the best.